All right, so day 6 is square root and cube root functions. Make sure you have your calculator. Go ahead and type in this function, the square root of x. So I'm going to go to my calculator, then I hit y equals, and I'm typing in the square root of x. And then I move over 1. Graph it and see what it should look like. Do you have this picture on your screen?
Yeah.
You have to do that? That's it for you?
Yeah, this is like
Okay. So let's go to second graph and look at our table. You should see a bunch of errors. Do you see this? All right, so wherever the errors stop is our starting point. So we're starting where?
0.
0, 0. So our starting point is 0, 0. Okay? Go back to your graph. I want you to tell me some other points. Skip the whole numbers. Sorry, skip the decimals. So 1, 1, 4, 2, and 9, 3. So let's write those in. 0, 0. So we have 1, 1, 4, 2, and 9, 3. Once you have those points in your chart, go ahead and plot them as best you can. And then connect the dots. Okay, so that's what it looks like on our screen. That's what we just plotted with our points that we got from our table. All right, my domain. You can't forget this stuff. All right, here's my domain. If I'm going from left to right, look at my x-axis, my graph starts at 0, and it goes on to where? Positive infinity. So my 0 is going to get a bracket because that number is included, and my infinity is going to get a parenthesis. All right, my range, we know that range is from down to up. Okay, so from down to up, look at your y values. Where does this graph start? Your y, no, looks like it's at 0, right? We're going from 0 up until positive infinity. You also need a bracket on that 0. It keeps going up and up and up towards positive infinity. My y-intercept. That means, where am I crossing the y-axis? Where's that at? 0. You can write y equals 0, or you can write the point. 0, 0. I'm okay with either way. You don't have to do both. So where do I cross the x-axis? At the same spot, right? So x equals 0. And so my 0 would also be 0, 0. It's a good hour, dude.
I don't know, the computer just froze on her midway through it.
Alright, well, you missed a lot. We're on day 6. We're just starting the packet. You just missed your mini quiz. And the homework review. Alright, increasing and decreasing interval. Okay? Increasing and decreasing intervals, we always look at my x values. Okay? So, increasing and decreasing intervals, I'm increasing from 0, and I'm going all the way towards infinity. For your intervals, you always have parentheses. Am I decreasing at all?
No.
No. We're not decreasing at all. Alright, my right in behavior. What is this arm over here? What's that right in behavior doing? Is it going up or going down? It's going up towards positive infinity. Any questions on square root parent functions? Our square root parent functions look like eyebrows, kind of. Okay, keep that in mind. That's what the graph looks like. All right, grab your calculators. Let's type in the cube root of x. So grab your calculator, go to y equal, clear it out. We're going to do cube root, so math, down to number 4. That's my cube root of x. Oh wait, let's graph it first. Where does it look like the center is at? Looks like it's in the origin, right? At 0, 0. All right, let's go to my table. I'm going to pick some points, okay? My center is going to be at 0, 0. I'll show you how we'll know that for sure. And I want you guys to tell me 2 points above it, 2 points below. The first one was what, -1, -1? All right, what's the next point? And you keep scrolling up. That's not a decimal. I have -8 and -2. All right, no, so the other way. If I go below 0, 0, 1, 1, and then 8, 2. Good. Go ahead and plot those points. 0, 0. All right, once you have your points plotted, try to connect your dots as best you can. It should look like a snake. All right, so let's imagine that this radical is longer than what we see. And let's say that we have a +0 under the radical and then +0 out of the radical. That's what this equation basically is. It's just we don't have to write the zeros there. If I were to do this, I can tell that my center would be the opposite of the number inside of the radical, and your last number would stay the same. So here's an example. Let's say that we have the cube root of x minus 4 plus 2. What is your center point? What's the opposite of -4? 4. And what is this number stays the same? So your starting point or your center point would be 4, 2. Okay? If there was no number here, let's say your equation looked like this. Then my center would be what? 0, 2. Good. Alright? So you can also do it that way by looking at your equation, or you can type it in your calculator and see what it tells you. My center is going to be 0, 0. All right, so my domain for cube root parent functions, or cube root functions, I'm going left as far as I can. I'm going right as far as I can. They both have arrows. So my domain should be what? How far left and right do I go? Yep, negative infinity to positive infinity. Good. Same with your range, okay? As your graph keeps stretching out, it's going to go lower and higher. So that will also be negative infinity to positive infinity. My y-intercept, where am I crossing the y-axis? At 0. Yep, I can tell that from my graph, and I can tell from my table because I'm looking for where x is 0. That's my y-intercept. Same for my 0. Where am I crossing the x-axis? 0. All right, increasing intervals from left to right. Where do I start increasing? The whole time, right?
Yeah.
So I am increasing from negative infinity to positive infinity. There's nowhere that I'm actually starting. I'm just going the whole time. Am I decreasing at all?
No.
No. All right, your left in behavior. What is this guy doing? Going up or going down? Going down? Nope, it's going down. It's going to keep going further and further and further down. And what about this guy over here? It's going to go up towards positive. All right, this is something you've also seen before. It does not go away. Your transformations. The same transformations work for cube root and for square root. So this a that is out front can tell me 3 things. Okay, if it is negative or if it reflects, we know because of what?
Negative.
There's a negative there. Take that one away. Okay, if your first number is negative, it's going to flip, it's going to reflect. How do I know if it stretches? My a has to be what than 1? Bigger than 1. And if it compresses,
Small.
smaller than 1. Meaning it has to be a fraction less than 1.
There can never be like negative 1/2.
It could. It would reflect and compress. That 1/2 is less than 1, and that negative reflects. All right, my h, which is under my radical. You guys good?
Yeah.
My radical tells me 2 things. Sorry, my negative h can tell me 2
I'm
things.
sorry, I'm sneaking out because Isaac starts to sleep. Mr. Smith has my class, but I'm going to leave this.
Okay, sounds good. All right, so if it goes left, your number will be positive. So that means you would have a plus sign. And if it goes to the right, how do we know?
Look at things.
It'll be a negative, which is a
Minus.
minus sign. Remember, we look at the word left and we see 2 plus signs, which reminds us we need to have a plus sign. All right, this plus k at the very back can tell me it shifts 2 ways. All right, if it goes up, how do I know it goes up? It's positive. And if it goes down, it is negative. Any questions there? Okay, this stuff is not new. Just new with some of the functions. All right, so how does the graph g of x equals negative times the square root of x minus 3 plus 2 move from the parent function, which is our original? Okay, So there are three different transformations there. What are they? Yeah, it reflects, or you can write flip. Alright, it reflects. What else? That -3 tells me to go which way? Right. 3. And then we're going to go up 2. Alright, my second question says, how does the graph g of x equals 5 times the square root of x plus 1 minus 3 move from the parent function? Alright, so I'm going to highlight my 5, my plus 1, and my minus 3. Those all tell me how to move. That 5 tells me to move how? I'm going to stretch by 5. Alright, plus 1 tells me what?
That's one.
Left 1. And then my minus 3?
Down three.
Down 3. All good on this page? Alright, let's practice. Let's see if we remember. If I look at my equation, what's my starting point? What's the number under the radical? There's nothing there, so I can assume it's plus 0. So that would be 0, and my last number stays the same. 2.
So if the radical made it to 2, it would be 2, 0?
Yes. So because there's no number under the radical, we just know that it's 0. What's my transformation here?
Zero.
I stretch by 2. And then what's that last plus 2 tell me to do?
That's
Nope, it's outside the radical. So down is plus up. There we go. Up 2. So grab your calculators. Let's type this in. So 2 times is what? Square root? 2 times the square root of x. Make sure if you have, so on all of your calculators, actually I'll show you. Alright, on your calculators, you're going to have, what was it, 2 times the square root of x, right? Does yours come up with the parentheses? No? Oh, okay. Just make sure you slide over. Okay? Slide over and then you hit plus 2. You don't want to put that plus 2 under your radical because that's not where it needs to go. I thought you guys had this calculated, but since you don't, go back to the one that I was using. Okay, did you guys get this? Alright, let's hit second table. Do you guys have that we're starting at 0, 2? Jennifer, do you have it?
No. So that option bar that makes it all the way to the 2.
You gotta scroll out of that. So once you type it in, the square root of x, move it over to the, I guess to the right. So it comes out of the bar, and then you hit plus 2. You have it, Isaac? Eric, you have it?
0, 2.
Let's get over to this. Yes. If you don't scroll over and you put that plus 2 under your radical, your answer is wrong. Look at your picture, it should look like this.
That's not this. I'm at 196.
Huh?
Look, it took me to 196.
Oh, really?
Yeah.
Alright, so I can show you. Are you scrolling down?
I'm scrolling all the way up. Because it was at like 100, it was 109 something. Wait, so what did I see this? Nice one, just calculating.
Table set, so we'll start at. There's a way that it's email down quicker. Okay, so you should have 0, 2, 1, 4, and 4, 6. 0, 2, 1, 4, 4, 6. Graph those numbers. 0, 2, 1, 4, 4, 6. That's what your graph should look like. All right, my domain. If I'm looking from left to right, where does my graph start? 0, because we're looking at our x values. So my domain is from 0 to infinity. That 0 needs to get what? A bracket. Infinity gets a parenthesis. My range, if I start from the bottom and go up, look at your y values, where does my graph start? At 2, and it goes up to where? 2 to infinity. And that 2 needs a bracket. That number is included. Alright, my y-intercept. Where am I crossing the y-axis? So y equals 2. Or you can write 0, 2, if you want to write as a point. Do I have any zeros? Am I touching the x-axis? No. Increasing and decreasing intervals. I am increasing, remember we're only looking at your x values for increasing and decreasing. So I'm increasing starting here, which is 0, and I'm going up all the way to infinity. Remember, your increasing and decreasing is always parentheses. Am I decreasing at all? No. My right end behavior is going up towards positive infinity. Once you guys are done with that one, I want you to try number 2. Then we'll check it. Down. That's covered. Down. Ladies. Down. Thank you. All right, number 2. What'd you guys get for your center point? What kind of 1? Opposite the first number, keep your last number the same. If you type it into your calculator, the 2 times the cube root of x plus 1 plus 3. So we have 2 times the cube root of x, was it plus 2? Or plus 1?
Plus 1 plus 3.
Plus. Okay, thank you. Okay, so let's graph it. Looks like there's like a little gap in it, but I don't know what that's about. Alright, so we go to our table. Here we go, -1, -3. And I'm going to pick 2 numbers higher, 2 numbers below. So -2, 1, 0, 5. I'll write my table at the bottom because I don't have much room. And you guys don't have to use a table. But I do want to know where we plot my points. What was the one above this?
Oh, the one above it?
Yeah. -2 something?
-2, 1.
And then I think
And
there's
then if you
a,
did 1, 3.
what about higher than that? Is it like negative 9 or
Oh.
something?
Yeah.
And then the other way,
With zeros.
and then 7. Thank you. Alright, so negative 2, 1, negative 9, negative 1, 0, 5, 7, 7. Alright, so that's what my graph looks like. I'm going to try my best to connect these dots. Oh, almost. Alright, thank you. Alright, my transformation, I have 3 of them. What's my transformations here?
Stretch.
We're going to stretch 2, okay? The +1 tells me to do what?
Left 1.
Left 1,
Up 3.
up 3, good. My domain is what?
Negative.
Positive infinity. And so my range is good. My y-intercept, I'm crossing the y-axis at negative 5. Oh wait, positive 5. You look in your table where x is 0, you'll find it. My 0 is not in my table, so we can estimate. I would say negative 3. But my drawing is not drawing the scale, so just estimate on that. I'm increasing from where?
Negative 4, 0.
Negative what?
4.
No, we're increasing even down here.
4.
For these cube root graphs, I'm increasing the whole time or I'm decreasing the whole time. So if I'm increasing, can I be decreasing? No. All right, left end behavior is going to keep going down further towards negative infinity. And my right end behavior over here is going to keep going up towards positive infinity. All right, I have one more thing to show you before the bell. Let's skip over the ones in the middle, and let's go to 7 and 8. All right, 7 and 8. What we're going to ask ourselves is, if I'm originally supposed to be starting in the center, how did I end up at this new graph that they have plotted? What's my transformation? What did I do to get from part 1 to part 2? Huh? Did I go up, down, left, right, what? Well, I went left 2. How many did I go up?
3.
Went up 3. Those are my 2 transformations. Left 2, up 3.
Ms. Crawley's personal secretary is returning Ms. Mitchell's calculator.
Oh, sweet. Thanks.
Sorry.
I'll let her know.
Did not mean to interrupt.
No, you're fine. All right, well, we'll get there. My equation here must start with y equals. Because I have an eyebrow looking graph, will that be square root or cube root? Square root. All right, after my x, I need to describe either left or right. So I'm going left 2. How do I write that in my equation? +2, good. And then up or down, I write behind my radical. How do I write up 3? +3. That is your equation. The best way to check your equation after you do something like this is to just type it in. Easiest way. All right, the second one, let's say that I'm supposed to have an apparent function, my centers and the origin. How do I get from this part to this center right here? What did I do? Well, you can't say over, left or right.
Right.
Okay, what else? Up 3. All right, am I increasing or decreasing here? This is going up or down, from left to right? Down, so I'm going to also reflect. Because it is upside down, or flip. So for my equation, you always start with y equals. Because I have a snake-looking graph, I know it is going to be a cube root. How do I show reflection?
Negative. Oh, you put a negative one.
Or just a negative, that's fine. Put a negative out front of your radical. Alright, inside my radical, after the x, how do I show right 1?
Minus.
Minus 1, and how do I show up 3? Plus 3 outside the radical. Okay, so here's the deal. Your test is next class. Okay, what I'm going to do is I'm going to give you a review sheet. This review covers everything that we've done in these 6 lessons or 5 lessons that we've already been over. We will go over it next class. This review is worth 20 points. So you don't have to do homeworks E and G or whatever is in your packet, okay? This covers that. Does that make sense? Okay, you're not doing the homework in your packet, you're doing this. On test day, I will still collect your packet and I will collect your review guide. And you'll get points that way.
Test is Wednesday.
The test is Wednesday.
And if it snows?
And if it snows and we don't have school, then your test will be when we get back. Okay? But do not lollygag and just forget to do this review. It is long, but it is very important. If you do this review, then you will do very well on your test. Does that make sense? All right.
Excuse this, sir, for some math to do now.